ह्यूमन रिप्रोडक्शन पढ़ूंगा और रिप्रोडक्टिव हेल्थ और सेक्सुअल रिप्रोडक्शन फॉर प्लांट्स कंप्लीट करना होगा इस यूनिट का। तो चलिए फटाफट शुरू करते हैं। As you are aware, humans are sexually reproducing and viviparous animals. The reproductive events. Hello, hello. কেমন আছো? হ্যাঁ, ফ্যান চলছে। ও, ভালো আছো? अभिषेक दिक्कत है। स्टडी করছি। स्टडी आई एम स्टडिंग। अभिषेक स्कैटर कहाँ से हो? रूपम घोष कहाँ से हो? कोथा থেকে? Okay, let's start. As you are aware, humans are sexually reproducing and vivivorous. The reproductive events in humans include formation of gametes, that is gametogenesis, sperms in males and ovum in females, transfer of sperms into the female genital tract, that is known as insemination, inclusion of male and female gametes, leading to formation of zygote. This is followed by the formation and development of blastocyst and its attachment to the uterine wall, embryonic development, gestation and delivery of the baby, parturition. You have learned that this type of reproductive events occur after puberty. There are remarkable differences between reproductive events in male and in female. The formation of zygote followed formation and development of blastocyst, attachment to the uterine wall, implantation, embryonic development, gestation, and delivery of the baby, parturition. So today we start from the gametogenesis. It is very confusing. Babunda, Tata. The primary sex organ, the testes in males and the ovaries in females, produce gametes. Sperms and ovums respectively by the process called gametogenesis. In testes, the immature male germ cell produces sperms by spermatogenesis that begins at puberty. The spermatogonia present on inside the wall of the seminiferous tubule. The spermatogonia present inside the wall of the seminiferous tubule. Spermatogonia. Spermatogonia present on inside the wall of seminiferous tubule, multiply by mitotic division and increase in number. Each spermatogonia is diploid and contains 46 chromosomes. Each spermatogonia is diploid and contains 46 chromosomes. Some of the spermatogonia called primary spermatocytes periodically undergoes meiosis, leading to formation of two equal haploid cells called secondary spermatocytes, which have only 23 chromosomes each. The spermatogonia present on the inside wall of the seminiferous tubules multiply by mitotic division and increase in numbers. The spermatogonia present on the inside wall of the seminiferous tubules multiply by mitotic division and increase in numbers. primary sex organ, the testes in males and the ovaries in the females produce gametes. The spermatogonia present on inside the wall of the seminiferous tubule multiply by spermatogonia present inside the wall of the spermatogonia present inside the wall of the seminiferous tubule multiply by mitotic division spermatogonia present inside the wall of the seminiferous tubule multiply by mitotic division and increase in number. Seminiferous tubule multiply by meiotic division and increase in numbers. Jyoti Kumari, happy Holi brother. Happy Holi to you also Jyoti Kumari. आपको भी हैप्पी होली. Spermatogonia present inside the wall of the seminiferous tubule multiply by mitotic division and increase in number. Next is हाँ ड्रॉपर हूँ. मैं ड्रॉपर हूँ. मई में एग्जाम है. मई महीना में. चलिए spermatogonia present inside the wall of the cell due to tubule multiplied by mitotic division. हाँ, फिजिक्स वाला का टेस्ट देता हूँ, फिजिक्स वाला का टेस्ट देता हूँ। आप कहाँ से पढ़ाई कर रहे हो? The immature male germ cells will produce sperm by spermatogenesis. Immature male germ cell produce sperms by spermatogenesis. मैं कोई बैच नहीं लिया, मैं सिर्फ टेस्ट सीरीज लिया हूँ, टेस्ट सीरीज टेस्ट देता हूँ। Immature male germ cell and immature male produce sperms by spermatogenesis. Next is conium is diploid and contains 46 chromosomes. Some of the spermatogonia called primary spermatocytes periodically undergo meiosis. Each spermatogonium is diploid. Each spermatogonium is diploid and contains 46 chromosomes. Okay, each spermatogonium is diploid and contains 46 chromosomes. Some of the spermatogonia called primary spermatocytes periodically undergo meiosis. Some of the spermatogonia called primary spermatocyte periodically undergo meiosis. The primary spermatocyte completes the first meiotic division, leading to formation of two equal haploid cells called secondary spermatocytes. And completes first meiotic division, forms secondary spermatocyte, 4 haploid, formation of two equal haploid cell, undergo meiosis and completes the formation of two equal haploid cells. The formation of two equal haploid cells called secondary spermatocyte. Okay. which have 46 chromosomes each. Each spermatogonium diploid and contains 46 chromosomes each. Primary spermatocyte completes the first meiotic division, leading to formation of two equal haploid cells called secondary spermatocyte, which have only 23 chromosomes each. A primary spermatocyte completes the first meiotic division, reduction, division, leading to formation of two equal haploid cells called secondary spermatocyte, which have only 23 chromosomes each. A primary spermatocyte completes the first meiotic division, leading to formation of two equal haploid cells. Two equal haploid cells called secondary spermatocyte, which have only 23 chromosomes each. The secondary spermatocyte undergoes second meiotic division. The secondary spermatocyte undergoes second meiotic division and produces four equal haploid spermatids. The spermatids are transformed into spermatozoa by the process called spermiogenesis. After spermiogenesis, sperms get embedded in the Sertoli cells and are finally released from the seminiferous tubule by the process called spermiation. The secondary spermatocyte second meiotic division takes place করে তারপর 4 equal haploid spermatids বানায় after spermiogenesis. So spermatids are transformed into spermatozoa by the process called spermiogenesis. After spermiogenesis, sperms will become embedded in Sertoli cells and are finally released from the seminiferous tubule by the process called spermiation. So, secondary spermatocyte second meiotic division, leading to formation of four equal spermatids. Forms four equal spermatids, and these spermatids are now transformed into spermatozoa sperms by the process called spermiogenesis. These spermatids are transformed into spermatozoa process is known as spermiogenesis. And then after spermiogenesis, the sperm cell embedded in the Sertoli cells. After spermiogenesis, sperms get embedded in Sertoli cells and finally released from the seminiferous tubule. Called spermiation. अजान, हेलो भाई, कैसे हो अजान? मैं बढ़िया हूँ। बढ़िया चल रहा है अभी। आपका कैसा चल रहा है? चलिए, बहुत बढ़िया। So the total process, the immature testes, the immature male germ cell produce forms by spermatogenesis that begins at puberty. The spermato ठीक है भाई, अच्छा चल रहा है आपका। The spermatogonia are present. Spermatogonia are present in the centripetal tubule, and by multiplied by multiplication increasing number, the spermatogonium then produce is declared in contains 46 chromosome. Some spermatogonia called primary spermatocyte divides meiotically, meiotic division leading to formation of two equal haploid cells called secondary spermatocyte. Then secondary spermatocyte, then second meiotic division, 23 chromosomes each and 4 equal spermatids, and then spermatids are transformed into spermatozoa by the process spermiogenesis. After spermiogenesis, sperms are embedded in circular cells and are released from the seminiferous tubules by the process of spermation. Okay. Spermatogenesis starts at the age of puberty. Spermatogenesis starts at the age of puberty due to significant increase in the secretion of gonadotropin releasing hormone. Spermatogenesis starts at the age of puberty due to significant increase in the secretion of gonadotropin. Thank you, Advocate Gamer, for telling this. Spermatogenesis starts at the age of puberty due to the significant increase in gonadotropin releasing hormone, and this is a hypothalamic hormone. The increased level of GnRH then acts at the anterior pituitary gland and stimulates the secretion of two gonadotropins, that is luteinizing hormone and follicle stimulating hormone. LH acts at the Leydig cells and stimulates synthesis and secretion of androgens. Androgen in turn stimulate the process of spermatogenesis. FSH acts on Sertoli cells and stimulates secretion of some factor which helps in the process of spermiogenesis. So spermatogenesis starts at the age of puberty due to the significant increase in the secretion of gonadotropin releasing hormone, and this is, if you recall, is a hypothalamic hormone. And the increased level of GnRH then acts at the anterior pituitary gland and stimulates the secretion of two gonadotropins, luteinizing hormone and follicle stimulating hormone. LH acts at the Leydig cells and stimulates the secretion of androgens, and androgens in turn stimulate the secretion of process of spermiogenesis, spermatogenesis, androgen in turn stimulate the process of spermatogenesis, that is, immature male germ cell produce sperms by spermatogenesis. FSH acts on the Sertoli cells and helps in spermiogenesis. So LH acts on the Leydig cells and stimulate the synthesis and secretion of androgens. Androgen in turn stimulate the process of spermatogenesis, which is the immature male germ cell to to the production of sperm, and FSH acts on the Sertoli cell and helps in stimulate the factors of spermiogenesis. Okay, let's read one more time. The primary sex organ, the testes in males and the ovaries in females, are the female produce gametes, sperms and ovum respectively by the process called gametogenesis. In testes, the immature male germ cell spermatogonia produce sperms by spermatogenesis that begins at puberty. The spermatogonium present inside the wall of the seminiferous tubule multiply by mitotic division and increase in number. Each spermatogonium is diploid and contains 46 chromosomes. Some of the spermatogonia, called primary spermatocytes, periodically undergo meiosis. A primary spermatocyte contains the first mated division leading to the formation of two equal haploid cells called secondary spermatocyte, which have only 23 chromosomes each. The secondary spermatocyte undergo second mated division and form spermatid, and then the spermatids are transformed into spermatozoa by the process of spermiogenesis. After spermiogenesis, sperm cell becomes embedded in a Sertoli cells and finally released from the seminiferous tubule by the process called spermiation. Spermatogenesis starts at the age of puberty due to significant increase in the secretion of gonadotropin releasing hormone. This, if you recall, is a hypothalamic hormone. The increased level of GnRH then acts at the anterior pituitary gland and stimulates the secretion of gonadotropins, luteinizing hormone, and follicle stimulating hormone. LH acts at the Leydig cells and stimulates the synthesis and secretion of androgens. Androgen in turn stimulate the secretion of spermatogenesis, which is immature male germ cell to sperm. FSH acts on the Sertoli cell and stimulate the process of spermiogenesis. Now let us examine the structure of sperm, which is it is a microscopic structure that is composed of a head, neck, and a middle piece, and a tail. A plasma membrane envelops the whole body of the sperm. The sperm head contains an elongated haploid nucleus. Okay. A plasma membrane envelops करता है whole body of sperm. The sperm head contains an elongated haploid nucleus, the anterior portion of which is covered by a cap-like structure that is acrosome. The acrosome is filled with enzymes that helps the fertilization of the ovum. The middle piece possesses numerous mitochondria which produce energy for the movement of tail that facilitates some motility essential for fertilization. The human male ejaculates. Okay, the Middle piece possesses numerous mitochondria. Middle piece possesses numerous mitochondria which produce energy for the movement of tail, will facilitate the sperm motility essential for fertilization. The human male ejaculates about 200 to 300 million sperm during a coitus, of which for normal fertility at least 60% of sperms are normal shape and size, and 40% of them must show vigorous motility. Sperms released from the seminiferous tubule are transported by the accessory ducts. Secretion of epididymis, vas deferens, seminal vesicle, and prostate are essential for maturation of motility of sperm. Accessory ducts. Sperm released from the seminiferous tubule are transported. Sperm transported by accessory ducts that are secretions of epididymis, vas deferens, seminal vesicle, and prostate. And the seminal plasma along with the sperm constitute the semen. The function of male accessory ducts and glands are maintained by testicular hormone, that is androgen. Androgen maintains the all male accessory glands are maintained by the testicular hormone androgen. Next is the process of formation of mature female gamete is called oogenesis. The process of formation of mature female gamete is called oogenesis, which is markedly different from spermatogenesis. Oogenesis is initiated during the embryonic development, and a couple of million gametes, mother cells, are formed within each fetal ovary. No more oogonia are formed and added after birth. These cells start division and enter into phase 1 of the meiotic division and get temporarily arrested at that stage called primary oocyte. Each primary oocyte then gets surrounded by a layer of granulosa cells and then called the primary follicle. A large number of these follicles degenerate during the phase from birth to puberty. Okay, so I need a 2 minutes of break for tea. Right? Okay, so we were reading oogonia. The process of formation of female mature gamete is called oogonia, which is markedly different from spermatogenesis. Oogenesis is initiated during the embryonic development stage when a couple of million gametes, mother cells, are formed within each fetal ovary. When a couple of million gametes are formed within the body, within each fetal ovary, no more oogonia are formed and added after birth. This cell starts dividing and enter into process 1 of the meiotic division. These cells start and enter into the process 1 of the meiotic division and get temporarily arrested at that stage, called primary oocyte. Each primary oocyte then gets surrounded by a layer of granulosa cells called primary follicle. So the cell starts division and enter into process 1 of the meiotic division and get temporarily arrested at the stage. The cells start division The cells start division and enter into process 1 and get temporarily arrested at the stage called primary oocyte. Each primary oocyte then gets surrounded by a layer of granulosa cells, then called primary follicle. Okay, the cell starts division and enter into process 1. Cells start division and enter into process 1 and of the meiotic division and get temporarily arrested at that stage called primary oocyte. Then the primary oocyte surrounded by layers of granulosa cells that are called primary follicle, and a large number of these follicles degenerate during the phase from birth to puberty. A large number of follicles degenerate these phase from birth to puberty. Therefore, at puberty, only 60,000 to 80,000 primary follicles are left in each ovary. The primary follicles get surrounded by more layers. अभय, हेलो मेरा भाई, हाँ हाय, हैप्पी होली, आपको भी हैप्पी होली अभय। प्रिपरेशन अभी ठीक ठाक चल रहा है, बढ़िया। जब से लाइव कर रहा हूँ तो ठीक ठाक ही चल रहा है। पहले थोड़ा बैठा रहता था, ओवरथिंक होता था, अभी चलिए ठीक ही चल रहा है। आप बताइए आपका कैसा चल रहा है सब? आपका कैसा चल रहा है पढ़ाई? ओके भाई, पढ़ाई आप कीजिए, अच्छे मार्क्स लाइए, होली खेलिए आप। A large number of these follicles degenerate during the phase from birth to puberty. Therefore, at रजनी हाय, अभय ठीक है भाई, रजनी हाय। A large number of these follicles degenerate during the phase from birth to puberty. Therefore, at puberty, only 60,000 to 80,000 primary follicles are left in each ovary. The primary follicles get surrounded by more layers of granulosa cells, and a new theca is formed called secondary follicles. And a new theca is formed called secondary follicles. बोल बोले पढ़ाई कौन करता है? मैं करता हूँ जी, बोल बोल के पढ़ाई मैं करता हूँ, नहीं तो याद रखने में दिक्कत होता है मन में पढ़ने से, ठीक है। The secondary follicle soon transforms into tertiary follicle which is characterized by fluid filled cavity. अच्छा, अभय भी करता है, देखिए अभय भी करता है बोल बोल के पढ़ाई। The secondary follicle soon transforms into a tertiary follicle which is characterized by fluid filled cavity called antrum. The theca layer is organized into an inner theca interna and an outer theca externa. हाँ, नींद आ जाता है, आप मुझे भी आता है अगर मन में पढ़ता हूँ तो। रजनी शायद मन में पढ़ती है। The theca layer is organized into an inner theca. Okay, the secondary follicle soon transforms into tertiary follicle and which is characterized by fluid filled cavity called antrum, जो कि fluid filled cavity से भरा होता है, antrum बोला जाता है। The theca layer is organized into an internal. All the best to you also. आपको भी all the best. Thank you. आपको भी all the best. The secondary follicle transforms into a tertiary follicle which is characterized by a fluid filled cavity called antrum. The theca layer is organized into an inner theca interna and an outer theca externa. हाँ भाई, फिर मिलते हैं। अच्छा, मिलेंगे, आप फिर आइएगा। The theca layer is organized into an inner theca interna and an outer theca externa. It is important to draw your attention that this is at this stage that the primary oocyte within the tertiary follicle grows in size and completes its meiotic division. Meiotic division, it is an unequal division resulting in formation of a large haploid secondary stage oocyte and then a tiny first polar body. Okay. The secondary follicle transforms into a tertiary follicle which is characterized by a fluid filled cavity called antrum. The theca layer is organized into an inner theca interna and an outer theca externa. It is important to draw your attention that this is at this stage that the primary oocyte within the tertiary follicle grows in size and completes its first meiotic division. The primary oocyte within the tertiary follicle grow in size and completes its first meiotic division. It is an unequal division resulting in the formation of a large haploid secondary oocyte and the tiny first polar body. The secondary oocyte retains a bulk of nutrient-rich cytoplasm. The primary oocyte. The secondary oocyte retains a bulk of nutrient-rich cytoplasm of the primary oocyte. At present, we are not very certain about this. The tertiary follicle further changes into mature follicle or Jacquian follicle. The secondary oocyte forms a new membrane Okay. At present, we are not confirmed certain about the tertiary follicle further changes into mature follicle or Graafian follicle. The secondary oocyte forms a new membrane called zona pellucida surrounding it. The Graafian follicle now ruptures to release the secondary oocyte ovum from the ovary by the process called ovulation. So this whole process is very complex. First, the process of formation of mature female gamete is called oogenesis, which is markedly different from spermatogenesis. Oogenesis is initiated during the embryonic development stage when a couple of million gamete mother cells are formed within each fetal ovary. No more oogonia are formed and added after birth. These cells start division and enter into prophase 1 of the meiotic division and get temporarily arrested at each stage that stage called primary oocyte. Each primary oocyte then gets surrounded by a layer of granulosa cells and then called the primary follicle. Large number of these follicles degenerate during the phase from birth to puberty. Therefore, at puberty, only 60,000 to 80,000 primary follicles are left in each ovary. The primary follicles then get surrounded by more layers of granulosa cells, and the new theca are called secondary follicles. The secondary follicle soon transforms into a tertiary follicle, which is characterized by a fluid-filled cavity called antrum. The theca layer is organized into an inner theca interna and an outer theca externa. It is important to draw your attention that this stage, the primary oocyte within the tertiary follicle, grows in size and completes its first meiotic division. It is an unequal division resulting in the formation of a large haploid secondary oocyte and the tiny first polar body. The secondary oocyte retains a bulk of nutrient-rich cytoplasm. Then the first body. At present, we are not very certain about this. The tertiary follicle further changes into mature Graafian follicle. The secondary oocyte forms a new layer called zona pellucida surrounding it. The Graafian follicle now ruptures its ovum, the secondary oocyte ovum, from the ovary called ovulation. Mitosis, primary oocyte, cosmetic division, resulting in fluid plate, and 4. First polar body, first polar body, second polar body, ovum. Now we will read about fertilization and implantation. No. Pregnancy. No. Let's move from here still first. Menstrual cycle. The reproductive cycle in the female primates, example monkeys, apes and human beings, is called menstrual cycle. The first menstruation begins at puberty and is called menarche. In human females, menstruation is repeated at an average interval of about 28 to 29 days, and the cycle of the event starting from the menstruation till the next one is called menstrual cycle. One ovum is released ovulation during the middle of each menstrual cycle. The reproductive cycle in the female primates, example monkeys, apes and human beings, is called the menstrual cycle. The first menstruation begins at puberty and is called menarche. In human females, menstruation is repeated at an average day or the interval of 28 to 29 days, and the cycle even starting from menstrual till a new year. One ovum is released ovulation during the middle of each menstrual cycle. The major events of the menstrual cycle are shown in figure 13.9. Day 1, 2, 3, 4, 5, 7. Menstruation. Follicular phase from 9 to 13. and luteal phase from 15 day 14. Day 14 the ovulation done. Luteal phase secondary to say next cycle begins from the day. Okay. Menses. Follicular phase day 14 is the peak. Estrogen is increasing, progesterone is decreasing, but from the luteal phase progesterone is increasing. Follicular phase, luteal. The cycle starts with the menstrual phase when menstrual flow occurs and it lasts for 3 to 5 days. The menstrual flow results due to the breakdown of endometrial lining of the uterus and its blood vessels which form liquid that comes out through vagina. Menstruation only occurs if the released ovum is not fertilized. Menstruation only occurs if the released ovum is not fertilized. Lack of menstruation may be indicated pregnant. However, it may be also caused due to some underlying causes like stress, poor health. This phase, the menstrual phase is followed by follicular phase. During this phase, the primary follicles in the ovary grow to become a fully mature gravid follicle and surrounded endometrium or uterus regenerates through folliculation. These ovarian induce changes in the levels of pituitary and ovarian hormones. Gonadotropin and LSH and FSH increases gradually during the follicular phase, which inhibits follicular development as well as secretion of the estrogen by growing follicle. Both LH and FSH happens at a peak level of middle 14-day. Rapid secretion of LH leading to maximum level during that is called LH surge. Release of ovulation is known as LH surge. The ovulation is followed by the luteal phase, during which the remaining parts of the gravid follicle form as the corpus luteum. The corpus luteum secretes large amount of progesterone, which is essential for maintenance of the endometrium. Such an endometrium is necessary for implantation of the fertilized ovum and other events of pregnancy. During pregnancy, all events of the menstrual cycle stops and there is no menstruation in the absence of fertilizing. The corpus luteum secretes large amount of progesterone, which is essential for the maintenance of endometrium. The ovulation is followed by luteal phase, which the remaining parts of the transform as corpus luteum. The corpus luteum secretes large amount of progesterone, which is essential for the maintenance of endometrium. Such an endometrium is necessary for implantation of the fertilized ovum and other events of pregnancy. During pregnancy, all events of the menstrual cycle stop and there is no menstruation. In the absence of fertilization, the corpus luteum degenerates. This causes disintegration of the endometrial lining and marking a new cycle. In human beings, the menstrual cycle ceases around 50 years of age, that is termed as menopause. Cyclic menstruation is an indicator of normal reproductive phase and extends between menarche and menopause. It's Mr. Gaurav. Hi. Hi, Mr. Gaurav. Thank you for commenting. So this is over. Fertilization and implantation. During copulation, semen is released by the penis into the vagina. The motile consumes rapidly, pass through the cervix, enter into the uterus, and finally reach the junction of the isthmus and ampulla. Ampullary isthmic junction. Ampullary isthmic junction. Pass through the cervix, enters into the uterus, and finally reach the junction of the isthmus and ampulla of the fallopian tube. The ovum released by the ovary. The ovum released by the ovary is also transported by the ampullary isthmic junction where fertilization takes place. The ovum released by the ovary. The ovum released by the ovary is also transported to the ampullary isthmic junction where fertilization takes place. Fertilization can only occur if the ovum and the sperms are transported simultaneously to the ampullary isthmic junction. This is the reason why not all copulation lead to pregnancy and fertilization pregnancy. The process of fusion of the sperm with an ovum is called fertilization. During fertilization, the sperm comes in contact with the zona pellucida layer of the ovum and induces change in the membrane that blocks the entry of additional sperms. Thus, it ensures that only one sperm can fertilize an ovum. The secretion of the acrosome helps the cytoplasm of the ovum through the zona pellucida membrane. These induce the completion of meiotic division of the secondary oocyte. This induces the completion of the meiotic secondary oocyte. The secondary meiotic division results in the formation of second polar body and a haploid ovum. Soon the haploid nucleus of the sperm and the ovum fuse together to form a diploid zygote. One has to remember that the sex of a ovum decided to stage itself. Let us see how. As you know, the chromosome pattern human-female is XX in the male is XY. Therefore, all the haploid gametes produced by the female oval have the sex chromosome X, where in the male gametes form the sex chromosome could be either X or Y. Hence, 50% of sperms can carry to the X chromosome while other 50% carry to the Y. After fusion of the male and female gametes of the zygote would carry either double X or XY depending on whether the sperms carrying whether X or Y fertilize the ovum. The zygote carrying double X will develop into a female baby and XY to a male. The mitotic division starts at the zygote moves to the isthmus of the oviduct called cleavage to the uterus and forms 2, 4, 8, 16 blastomeres. The embryo with 8 to 16 blastomeres is called morula. The morula continues to divide and transforms into blastocyst. As it moves further into the uterus, the blastomeres are arranged into the outer layer called trophoblast. The morula further divides and transforms into blastocyst. Blastocysts are arranged in an outer layer called trophoblast and an inner loop of cells attached to the trophoblast called inner cell mass. The trophoblast layer then gets attached to the endometrium and differentiated as the embryo. After the attachment, uterine cells divide rapidly and covers in the endometrium. This is called implantation and lead to pregnancy. Attached to the uterine wall and get differentiated as embryo. The mitotic division starts at the zygote, moves to the isthmus of the oviduct called cleavage towards the uterus and forms 2, 4, 8, 16 daughter cells called blastomeres. The embryo with 8 to 16 blastomeres is called morula. The morula continues to divide and transform into blastocyst, and as it moves further into the uterus, the blastomeres in the blastocyst are arranged into an outer layer called trophoblast and an inner loop of cells attached to the trophoblast called the inner cell mass. The trophoblast layer then get attached to the endometrium and the inner cell mass get differentiated as the embryo. After that, the uterine cell divide rapidly and covers the blastocyst. pregnancy and embryonic development. After implantation, finger-like projections appear on the trophoblast, called chronic veili, which is surrounded by the uterine tissue and maternal blood. After implantation, finger-like projections After implantation, finger-like projections appear on the trophoblast called chorionic villi, which is surrounded by the uterine tissue, becomes interdigited and each other and jointly form a structural and functional unit between developing embryo fetus and maternal body called placenta. The placenta facilitates the supply of oxygen and nutrients to the embryo and also removal of carbon dioxide and excretory waste materials produced by the embryo. This placenta is connected to the embryo through a umbilical cord which helps to transport of substances to and from the embryo. Placenta also acts as an endocrine tissue and produces several hormones. The placenta facilitates the supply of oxygen and nutrients to the embryo and also removal of carbon dioxide and excretory waste materials produced by the embryo. The placenta is connected to the embryo through an umbilical cord. Again, after implantation, finger-like projections appear on the trophoblast called chorionic villi, which is surrounded by uterine tissue and maternal blood. The chorionic villi and uterine tissue become interdigited and each other and support form a living fetus and maternal body called placenta. Placenta facilitates the supply of oxygen and nutrients to the embryo and also the removal of carbon dioxide waste material produced by the embryo. The placenta is connected to the embryo through a umbilical cord which helps in the transport of substances to and from the embryo. Placenta also acts as endocrine tissue, produces several hormones like HCG, human chorionic human placental lactogen and progesterone. In the latter phase of pregnancy, a hormone called relaxin is also secreted by the ovary. Let us remember that HCG and relaxin are produced in women during pregnancy. In addition, during pregnancy, the levels of other hormones like estrogen, progesterone, cortisol, prolactin and thyroxine are increased several fold in maternal blood. Increased production is essential for supporting the fetal growth and the metabolic changes in the mother and maintenance of pregnancy. Immediately after the implantation, the inner mass cell differentiate into an outer layer ectoderm and then inner layer endoderm or mesoderm soon appear between the ectoderm and mesoderm. These three layers give rise to all tissues, organs in adult. It needs to be mentioned that the inner cell mass contains certain cells called stem cells which have the potency to give rise all the tissue and organs. What are the major features? HCG, HPL and estrogen progesterone. What are the major forms? Do you know? In dog, embryos heart is formed when the listening to the heart. By the end of the second month, the fetus develop limbs and digit. By the end of the first trimester, major organs are formed. 12 weeks, for example, limbs and digit are well developed. 12 first trimester development. The first movement of the fetus, appearance of hair and the head are usually observed during the 5th month. By the end of 24 weeks, the body is covered with fine hairs, eyelids and eyelashes are formed. By the end of 9th month, the fetus is fully developed and is ready for delivery. Parturition and lactation. The average duration of pregnancy is about 9 months, which is called the gestation period. Uterus contraction of the uterus at the pregnancy causes expulsion and delivery of the fetus. This process of the delivery of the fetus, childbirth, is called parturition. Parturition is induced by a complex neuroendocrine mechanism. The signals for parturition originate from the fully developed fetus and the placenta, which induced mild contraction, uterine contraction called fetal ejection reflex. This triggers the release of oxytocin from the maternal pituitary. Oxytocin acts on the uterine muscle and causes stronger uterine contractions, which in turn stimulates further secretion of oxytocin. The stimulation or reflex between the uterine contraction and the oxytocin secretion continues, resulting in stronger and stronger contraction. This leads to the expulsion of the baby out of the uterus through the birth canal, called parturition. Oxytocin fetal ejection reflex. Okay, the mammary glands of the female are now producing several antibodies. Okay, so this was the chapter which I read in short in 1 hour 22 minutes. Still is occupied. And about the mons pubis is a cushion of fatty tissue covered skin and pubic hair. The labia majora tissue fold of tissue which extends down from mons pubis and surround the vaginal opening. The labia minora are paired folds of tissue under the labia majora, and myometrium, perimetrium, endometrium. There are 3 layers: external perimetrium, myometrium, endometrium, ampulla, isthmus. Okay. As a functional mammary gland, the mammary gland have paired structure. There are 15 to 20 mammary lobes, alveoli is mammary tubules, mammary duct, wider mammary ampulla, then lacteal duct. The glandular tissue maybe breast to mammary lobes to mammary ampulla, mammary lobes to alveoli to mammary duct to ampulla to lacteal duct. That's it. The pair of liquids on their ovaries. Okay. The male acidic glands are seminal vesicle, a prostate, and the paired bulborectal gland. Rich in fructose, calcium, and certain enzymes. And accessory ducts and accessory glands are different. testes, alveoli ducts, gland and external genitalia. So this chapter is done. So human reproduction chapter is done. And now we'll move to the next chapter, that is reproductive health. And please subscribe, those who are watching this channel, please subscribe, it will be helpful for me. Now reproductive health, but before that tutorials were very small chapter. Okay guys, will continue this live session after 1 hour because I have an emergency. Okay, I have an emergency.